Welcome, everybody. We'll be talking about authorization in the microservices world. I'm Sitaraman Lakshmi Narayanan. I go by Ram, just for simplicity's sake. I'm a security architect at Pure Storage. Written a couple of books on web services security mostly. It's Oracle Web Services Manager or ASP.NET Security. I want to kind of walk through a few things before we get into the actual meat of the discussion, which is about open policy agent and stuff. There will be a lot of acronyms, so just feel free to stop and ask questions. The things that you commonly hear about on the authorization side is role-based access control, RBAC. It's about defining a role like administrator, manager, whatever role you want. But what the role actually means is somewhere in the code or the list of permission that tells you what the role can or cannot do. Or there is also another concept called attribute-based access control. It's about saying you can access this page or an API based on the location where you're coming from, your IP address, your age, and other information. So these are attributes that are derived based on your HR profile or other attributes. There is a notion of what is being called as policy-based access control right now, picking up right now. You can call it combination of role-based and attribute-based, but at the end of the day, it's about defining the policy in a way that says you can access this resource. Resource can be a page, API, whatever, for this user or a group, and what actions they can do, whether it is a get, post in terms of API terms, or is it create, delete, CRUD terms. And you add some conditions to it. Conditions can be, it has to be an IP address based or certain level of clearance, whatever it is. A good example on a policy-based access control would be AWS IAM policy. If you have configured that, you probably can relate to that. So what we will kind of go over is how did this authorization became so complex, right? It's very simple when you just look at one application, but if you're a large enterprise having to manage multiple different services, then it kind of gets out of control. And then when you apply this to microservices world, the question becomes is, how do I manage these many services with the different access permissions? It starts with role-based access control. We'll go over how the client-server application used to work before, and how we evolved into, when we moved into a web-based application or service-oriented architecture, where did this go? And then we talk about, is the concept of externalizing authorization, is it completely new, or was there anything in between built? And then we'll talk about, okay, what is OPA is about, what is Open Policy Agent, and how it can actually help you address this. So this is in the mid-90s, or late 90s when I started working, the client-server application, right? You build a rich client application and it connects directly to the database. You can think of your mobile application today. It has an API in between. You have a mobile app on your device, and there's an API server, and then there's a database server. But then what happens is, you're building a form. I am not a GUI designer, so I just pick something, whatever I could find to kind of relate to this. There's a reason why I didn't go into web or GUI development for some reason. You can relate to that. So you put up a page, and you're building a page, there are about tabs on it, and you say, okay, first name, last name, you're going to save, right? If you were to implement authorization, what used to happen is, what I've done some of this is, when you click that save button, you're going to say, okay, then this event gets triggered. You're going to say whether the form name is create customer, whatever it is, and then you're going to say, okay, if the user who's logged in, the role is administrator, manager, whatever it is. If it's there, then yes. If not, just deny access. You'll probably see this in your current code somewhere. No matter how the code is written, whether it is the client-server application, API, mobile app, you will be seeing some version of this right now. So then came the three-tier architecture model, right? So you have a client, and you have a web server, you have an API server, and then you have a database. So when you build these web applications, what happens is you will end up doing access control on the web page because you want to do fail fast. You end up putting controls on the web page saying who can actually view the page, who can actually click save, who can actually post. But then when you invoke the API, you want to make sure that can I enforce access control on the API. So when people started building the web application on the very first iteration, what happens was the control is basically based on the firewall. So your web server is on the DMZ, and you put the API server behind, and then you say that, okay, web server is accessible from the internet, my API server is behind, and it's controlled by firewall. Only the web server can talk to the API, and the API server can talk to the database. And these are the normal controls put in place. And then it's kind of evolved into, how many of you here heard of web access management product like Oracle Access Manager or Oblex, SiteMinder, Novel Access Manager, Sun Access Manager, right? When those products came along, you kind of say, okay, let's put those controls on the front. They will enforce the controls, so who can access the pages, and then they kind of set the headers or some kind of an attribute that your API can look up, and then you'll invoke the API. These APIs were SOAP XML-based web services API, right? But most of the time between the web and the API to the database, that it's implicit trust, either by firewall or some kind of a mechanism that we built into the code. Then one API server became multiple API servers, right? So then you started having this scenario where each team wanted to make their own API servers available. They started abstracting out all the business logic, started deploying API server. Once the API server kind of got out of hand, then the concept of API gateway came, right? So the Amazon API gateways today, it used to be a bunch of different web services security gateway before. The notion here is that your web server will talk to the gateway. Gateway will enforce all the authorization, authentication you need to do. Then the gateway will talk to the internal services. And then the internal services will have access to the database. So you end up start exposing a bunch of business domain-specific web services, SOAP XML web services. Then you put a customer-facing or external-facing API gateway. That's what your web application and mobile application today. I think this is even true today, because whether you call it cloud, mobile applications, whatever it is, you have some version of API gateway available that are in the perimeter that are enforcing security. Again, there are some acronyms here. WS security, SAML, these are single sign-on standards, right? So SAML was the single sign-on standard for identity management. WS security came in to say whether you can enforce authentication. It also kind of talks about whether you can do message level encryption, digital signatures. All of them came into place. WS trust is about how do I broker the trust between one domain to another domain. Whether you go from one web server to an API, one API server to a different API server, how do you do that? So once you put those APIs and accessible to the customers, customer-facing or web external-facing, then you have this challenge. Okay, I have all these local internal services that I don't want to be exposing. So you'll have these internal services. Those are your database CRUD services or any operation that you don't want to expose. Then you end up having an internal API gateway. So the trust is between the external API gateway to the internal gateway. Once you get past the internal API gateway, everything else is accessible. So the threat is if you're an insider, you can access anything you want, but when you're coming into the proper channel, you enforce all the security. So if we go back on the previous slide, right? So this is the authorization, right? But if you'll be enforcing authorization at the gateway layer, at the web application layer, and then the internal services if you want to do even more fine-grained access control. So that means your authorization logic is now in multiple places, right? So the gateway has some authorization policy on the external one that are customer-facing or your web application-facing, and the internal gateway has some additional trust built in, so you can let pass certain APIs without additional checks. And then within each API endpoint, you will be having your business logic-specific thing, right? There are only those domain-specific authorization rules. So what happens is every time you're building authorization at multiple layers and also within the code, it makes it harder to change the authorization rules without changing the code or without redeploying, without changing the configurations. Or if you take the gateway approach, again, I was one of those people who loved the gateway when the gateway came on, but then once you started putting them, you then start realizing the pain, right? Once you put all the gateway in place, what happens is now if it becomes bloated because you have now become, instead of being a microservices, individual services, you have one choking point. It becomes one single entry point, which means all the individual services that you're building are now gated through the gateway. It becomes bureaucratic. We'll have a slide to walk through why it becomes bureaucratic, right? The API gateways are normally owned by operations team, your application team, so building the API. Then it becomes challenging. So kind of a walkthrough process. A developer builds the API. He or she's they're going to document the endpoint, who can access this, and then some kind of a ticketing mechanism, deployment mechanism, whatever it is, you're telling someone else to configure the gateway to say which user, which role, which application can talk to your individual endpoints. And then once everything passes, your API gets invoked. Now repeat this for tens of hundreds of services you're going to build. Now your development becomes a bottleneck for your development teams. As we move from SOAP XML web services in mid to late 2000 into REST, I kind of lost the timeline on this when the REST actually started. That's the time also I switched from being application security to more into security. When REST came, they said, okay, REST is going to solve the problem. It's going to make it easier to develop. Single page applications came along. You can invoke the APIs. But then when you start looking at the security aspects of it, we just literally moved XML security into JSON based, right? All the questions that there is, I should have put the link in there. The slide I talked about WS security, SAML and everything else. There's a guy who authored all those specs, wrote an article that talks about we are reinventing the wheel on REST API JSON because you have JSON web signatures, the JSON web tokens, encryption on the JSON payload. So everything is getting taken a second look at it, but it's the same problem. So when you move from XML to JSON, you come into this concept of JSON web tokens. You would have heard this in different terms like OAuth, OpenID Connect. At the end of the day, it's a JSON web token. It has a JSON data. It's digitally signed. It can be optionally encrypted if you want to. At the end of the day, it represents information about the user, the application, the roles, whatever you want to put in the payload, and scopes. So an API endpoint, normal process is that when you go through the REST semantics, you have a REST API, then you pull an HTTP filter. How many of you familiar with or not familiar with what an HTTP filter is? Not familiar? Or okay, assume not familiar. So HTTP, if you're building an API, what happens is every HTTP request goes through a pipeline process. Your HTTP web server handles it. It looks at the request, it does authentication, it does all the auditing and everything else, right? As a developer, you get to write a filter on the pipeline to say, what can I do? Can I check authentication? Can I check authorization? And this is what, if you talk to any Java Spring developer, this is a very well-known concept. They put an @ symbol on top of every API endpoint, right? So that's what it is. I build and create customer API, and then I put an HTTP filter that says, here is my authorization. All this means is @auth means that it'll invoke a code that is registered as a component that says, okay, in this pipeline, before you actually invoke the API, go call this Java class that has this method.
Stuff like Spring Security.
It's just Spring Security has this, yeah, right. So validate jar token, right? First you want to authenticate first, and then once you've done the authentication, you can set any context you want, and then you do the authorization check to say, hey, is this user belong to this role? And my API says you have to be a manager, so let me go look up the database and see what it is. So again, now here is what happens, right? So your developer builds the API, they add the filter. When they add the filter on each API endpoint, they have this annotation that says this endpoint is allowed if you have the permission as create customer or you have the role as manager. And then the context will go and query the database, whatever it needs, it understands the authorization, and then you enforce it at the API layer. But the challenge is now you're kind of, the meaning of what a role means is on your API code, right? So a developer writes the API code, the declarative syntax says that you have to have this permission to invoke this, which means anytime you want to change any role, combination of that, you have to change the code. Which means anytime I tell the developer to change the code, you go through the texting process. But then gateways are, if you remove this from the code, then you have to put this on the gateway, and then when you put it on the gateway, you are increasing the operation head. So there is not really a win-win situation here, right? So, but you're taking a cycle on this whole thing. So how do we do this? So the concept is basically about externalizing authorization, right? So externalizing authorization is your code does what the business logic is supposed to do. It talks to an external endpoint to say what it is. So it's not just about gateway. So remember we talked about gateway is one version of externalizing the API, externalizing authorization decision. But then what we want to do is we want to make it developer friendly. As the developers start building application, they want to deploy it faster with the CI/CD process. We want to evolve security in the same direction. So that means we want externalizing authorization to be the same way you deploy a normal code, which means you don't want the gateway to be the only one solution. But gateway was not the only one that brought the concept of externalizing. I don't know if anybody here familiar with the standard called XAML? Okay. So XAML it has a very, SAML was for single sign-on around the same time when SAML was picking up. XAML was the standard for externalizing authorization. So the whole idea of XAML, extensible access control markup language, is I can have a policy definition, right? So I can go define what a policy should be is. This user, this role can access this resource, whatever rules, conditions, IP address, age restrictions, I can go define those things. And then I'll deploy something called policy decision point, which is making the decision. It is understanding what the request is. It talks to the policy definition to say, okay, what is my policy? It looks at the resource being accessed, the API URL. And then it makes the decision. It will go query your database to find out whether the user belongs to the role, their attributes, and other information. The policy enforcement point is the one that is very close to your code. Remember the HTTP filters we talked about. So it's basically, think of it as a library that makes a call to an external API to say, hey, here is the input. Can you tell me if this request is allowed or not? So I build an API endpoint. I build a filter that is, let's say in this case, a XAML compliant policy enforcement filter, which will gather all the requirements that are XAML specific. And then we'll invoke the XAML policy decision point that says, hey, is this user allowed to access this API under these conditions, whatever we are defined as a policy. So the policy decision point is available as APIs. It has built-in language syntax made in place. You build an enforcement point that integrates into your API platform, whether it is Node.js, Java, whatever you're doing, right? But this is the whole notion of externalizing it. So this concept of externalizing is not new, but it exists. But it did not get picked up or that much of an adoption because when you look at XAML, it's really good in theory, but if you look at the XML syntax, there is a huge XML syntax that you have to be aware of. So while you get the advantage of externalizing the code, and you also get the advantage of having someone else define the policies outside the code, outside the development team, either the security team of the product of the customer or the security team of the consumer, right? But the XAML integration required learning those specific language. What does the XAML syntax means? So that means you're now telling your development team to understand what those policy decisions are, how to construct those things, make the appropriate API call, understand the decision, and then say, can you externalize it? So, and there was not, as far as I can remember, there was not that much of an open source adoption. There is only one company that is still in doing along those lines. They have I'm trying not to be commercial, so they have a similar version for the REST API right now. So there's also another push, we'll talk later, on policy-based access control. So there's not that much of an open source integration available. So how do you do this externalizing authorization, but not having to be tied to, even though XACML was an open source standard, there was no real open source adoption. The option is you can build your own authorization API. So that means you build the API endpoint. It can be any API endpoint. It's similar to HTTP filters we talked about. It's a code that will understand your request, the user. It can query the database and then make the decision. But then here is how it'll look like. So you build your own authorization API. You build your client SDKs that will integrate with Java, Python, and everything else. And now you're making the request to the authorization API, and that will query the database. And you can build your own policies. Think of everybody familiar with Amazon IAM policies, right? So if you go look at Amazon IAM policies, it gives you a very nice syntax that says, here is my resource, here is what you can do, right? That's your policy builder GUI. You can build it. You have to store them in a database. Your authorization API will query them. You integrate with this. But then the challenge with this is that you own everything, right? You are building the authorization API. So that means there will be a security team or an application / product / security team combined together. You'll be building an authorization API. Depending on how big the organization is, you're building the client SDKs for Node.js, Python. Then suddenly you're looking like an Auth0 kind of company. Based on your enterprise, if it's standardized on one platform, then you can build the SDK easily. Then you also have to train the developers to say what the authorization API should look like, what the contract is. There's no open source community for them to go and look at how to get help. Yeah, this is it. Suddenly you're asking yourself, like, am I building feature X or am I a security company, right? So as the company grows big, the security then the issue starts to bubble up, customer starts asking more features, then you're saying, like, okay, what am I doing? Where do I draw the line? So we'll talk about Kubernetes. So I want to kind of segue from the history of all the challenges, having been through building your own authorization API. You looked at XACML to say, okay, now we are in the Kubernetes world, right? I'm assuming everybody heard the name Kubernetes. It's a container orchestration platform. It has very simple concept, right? So you have a Kubernetes API server. Every request goes through that API server. You have a Kubernetes dashboard, and you have a kube control CLI platform, command line. Both of them goes to the same API server, and by default, as a platform has its open source one. It has role-based access control. It also has attribute-based access control. That means I can go configure to say team X, manager, role, whatever, administrators can do whatever it is. I can go down to individual attributes and then say, here is the control I want. But not every customer, every company is going to be happy with what the Kubernetes attribute-based access control is, right? Instead, when you are deploying, if I pick any 3 people here, the way you manage your Kubernetes deployment in your organization is going to be completely different than the other 2, right? So that means, can I give access to team X to deploy any container I want? Can I give team Y to monitor whatever? So whatever authorization mechanism you want to do, Kubernetes provides a webhook that says, integrate with this webhook, and every API call will go through the webhook and then say, I'll make the decision. So in order to make the authorization decision, so let me go back a little bit here. So Kubernetes API, your dashboards, CLI, or any API directly, it will call, when the API gets called, it's going to delegate this to one of these authorization mechanisms that's configured. And when it returns a true or false, your API gets invoked, right? But whenever you're invoking an authorization API, what it does is, what is the resource being invoked, right? Whether you're deploying something or accessing what action, because in the Kubernetes world, everything is a resource, everything is an API endpoint, everything is tied to your HTTP verb, and you have the incoming user identity. So user identity can come from either username and password, you can have it, that means the user ID will be there, or it can be a JSON web token. So you can have a Kubernetes integrated with your single sign-on infrastructure. you get the JOT token coming in, and then it automatically extracts the information from the JOT token and gives it to the webhook, right? So all you have to do is you write a webhook, and that gives you allow or deny, and enable the webhook in your Kubernetes framework. So now, if you're taking the Kubernetes platform, installing in your organization, you get the flexibility of defining whatever authorization policy that your organization needs. You're not going to be tied by the vendor's access control. You don't have to say, okay, how do I define the role? How do I map my definition of admin in my team to a definition of what the platform tells me? So
Go
this.
back to that last one for just a second. Thank you. Thanks.
So a quick one is, like, so when you make a webhook authorization, what happens is Kubernetes gives you this information, right? It gives you what the API is, version you're invoking, and it kind of tells you, hey, the request I'm making is for subject access review, whether the user is allowed or not. And then it tells you, Kubernetes has a concept of namespace. So someone is trying to do a get on this namespace. I just took the sample from Kubernetes examples, right? Here is the group that the user belongs to. Here is a resource. Resource can be pods, custom resources you define, whatever it is, right? So it gives you all the information to your webhook that you're developing, right? Webhook is your API endpoint. So what this means is that you build the API, you understand what those object is being what type of object is being requested, and you have all the information. Now you can go make the decision based on what it is. You can say group 1 can, in this namespace, can do a get, but group 2 is not allowed. So you can do a get for administrator or secure administrator on everything, but post is only allowed for the individual team members, right? So you can have complete separation of duties, whatever you want. It's within your control of authorization policies. The thing is, the webhook, when it returns, it's going to return in a unified format. It says allowed equals true. So now you have a framework to say, okay, I have a simple request and I got a unified response. Based on this, I will make the decision as to whether to allow the request to go or not. So this is the Kubernetes way of things. So this is why I allow the Kubernetes authorization, because having been done this for over 15 plus years on both sides, building products as well as on the IT side, using somebody else's products, right? When I saw Kubernetes and their webhook authorization, I was really in love, because Kubernetes gives you the platform, but they don't dictate how the authorization should be enforced. There is no one size fits all like a role-based model. So every time you look at a role-based access control, you have to manage your process and policies to the vendor's role-based access control model. It's designed with API first, which means that anytime you want to enforce an operation, it comes into what is the resource, API resource I'm accessing, the individual objects, and then the get post method. This is a very classic example of externalizing authorization. You as a customer who's using Kubernetes, we get to define what the authorization is, how we want to enforce it, how we want to integrate it with our framework. So now we'll kind of segue into what about the services we are building, right? So Kubernetes is a platform. Now everybody starts building services. Microservices, heard the term. It's about building smaller scale services that are owned by individual teams. Now, with the Kubernetes adoption, there are too many services getting deployed. Every container has a service endpoint available, right? But then you still have to manage the authorization, because Kubernetes provides it for the platform, but this API that you're building on the containers that you're deploying are your business-specific APIs. So you cannot leverage what Kubernetes does, right? So on the same lines, ISTIO kind of brings them together and say, okay, how do I make it faster to deploy microservices on Kubernetes platform? This is a picture from the ISTIO website. I'm trying not to go too much into the ISTIO jargons. The idea is that ISTIO manages some of the networking, routing policies, and everything else. You build a service A, you build a service B. ISTIO acts like a proxy for you. It manages the protocol translations, mutual TLS authentication, everything else. So you get some of the benefits, but then you ask, how about authorization, right? Authorization is still going to be on local to the service that you deploy. So with ISTIO, just at a high level, you can have your own authorization. It gives you, anybody who has developed services, or if you're talking to your API teams, they have some way of understanding who's accessing what kind of log information I can get, what is my throttling quotas for the APIs, where do I go and deploy my service discovery, how do I discover which service can talk to what services, all of them. So these are high-level components, but at the end of the day, you can think of ISTIO as a proxy that gets embedded with your container deployment, right? So that it brings all those features, but then authorization is still going back to, instead of being on the code, it becomes YAML, right? So when you deploy an ISTIO-based services and enabling it, this is what you're saying. You're saying, okay, these services are accessible by, for this users, all the information. So it's yet another markup language. You're now, with YAML-based approach, yes, you're giving developers the control, but then they have to keep on redeploying every time you want to change some controls on the authorization rules. So while ISTIO hides all the complexity for which service can talk to what services, it can do mutual TLS authentication, but what happens is authorization is still left within every service deployment. So it is local to the services. It's not externalized. Now we are basically reinventing the wheel. We're going back to the client-server model. Each application has its own authorization embedded within the code, or at the proxy layer embedded within the container.
Might as well be another Spring filter.
Might as well be another Spring filter, right? So what do we do? How do we externalize this, right? So the challenge is we need to be able to externalize this so that we can change those authorization rules without having to rewrite the code. So if we agree on a standard or a standard way of communicating that says, what is the resource being accessed? Resource, I'm using the word resource because later on we will talk, the open policy agent applies for not just for API, it's for everything else you want. So a resource can be an API endpoint. The operations or actions, whether you're doing a command list on a host or you're doing a get post on an API. The identity of the caller and payload. Payload is if you want to do fine-grained access control, you need to have visibility into what is being requested on the API. Now, if you have all of them, then you can either build your own proprietary thing or you can kind of standardize on something else. So this is where Open Policy Agent comes in, right? So what Open Policy Agent tells you is that it kind of it's a policy engine that exposes as a REST API, which means you will be able to make your own decisions based on the data that is being posted, or it can query other resources. And then it will give you a decision that says true or false that you can use. So at a high level, you have an OPA service running, and your service endpoint makes a query, and it gives you a decision back to you. What does the OPA mean? OPA is basically a bunch of policy, which is authorization rules, authorization logic that you can deploy within OPA, and then say, if someone asking for HTTP authorization policy 1, it will evaluate, come back and tell you true or false. You can either have a data within the policy or you can query data from outside. It has its own query language. It's based on Rego. Rego came from Datadog. So we'll go a little bit more into the details. Policies are basically defined as a bunch of rules, and each rule evaluates into all the conditions are evaluated to an AND condition and comes back and returns you true or false. And each statement is basically an equal operation that you're checking. So here is how a package on the OPA policy would look like. You kind of give whatever name you want, right? If you're like, since we're talking about HTTP API, you can say HTTP API authorization policy. That's your package name. You can hard code the data in the policy. There are some other conditions. You say, okay, I want this user or this administrator to do certain things. Input is basically a keyword. So right, all the data that is when you're invoking we'll see later. When you're invoking the OPA policy API, the data comes in. You're just assigning a variable to it. So this is the rule that says allow within the brackets. These are individual statements, right? So what this means is that if the HTTP API, which is an input variable that you have, if the method is get, and if the path that you're trying to access is one of them, and if the username is the one that I'm looking for, then yes, allow. So this is your HTTP filter, right? So if you're writing an API, what you're going to do is when somebody accesses an API that says /salary information, you want to make sure that, okay, what is the user? So you will query your HTTP context or the JAR token or somewhere else to say, hey, what is the user that is requesting this? And you will construct the information that you have, which is, okay, you're trying to access this path /finance/version1, whatever the path you're trying to access. And then you will query the method that says, you know what method it is, whether it's a get or a post or a patch, whatever method. And you can add additional data to it. You can just send the entire payload with this information if you want. And then all you're doing is you're making a REST API call to say /v1/data/ here is my, remember that HTTP API /auth, that is the package name that we had in the previous one. So that's how it works. So when you're basically calling that API and you're passing the JSON and you get back the result that says true or false.
So, is the JWT token already validated? I just want to know if the validation is already done before this.
This is the input you're sending to OPA. So the assumption is that the authentication is something you have already done.
Okay, so that we take care of that with an HTTP filter is what you're saying?
Yeah, instead of the HTTP filter, you'll be replacing your HTTP filter with making an external call like this.
Okay.
So this code can go into your HTTP filter if you want. Okay. And then you're making the call to say, now we can take this and put it into the ISTIO, which is the gateway, which is acting as a gateway.
Yeah, I saw the code where you take the username from the username, but yeah. I didn't see where you are validating the JWT token.
So that will be, sorry, that's the JWT token validation is assumed that you're doing it at a layer before the OPA. OPA is about authorization.
Yeah. Okay.
Yeah.
Okay. Thanks.
Yeah. So all you're doing is you're making a call to OPA and then say, okay, whether this input was valid or not. So the OPA evaluates it and then returns. So that means now with this example, you can go back and then say, anybody who's trying to access the finance or salary information, you can say now you cannot do this if you're coming from an XYZ IP address, and your security team comes and looks at it and then say, you have to have 3 more conditions. You know, so if you're looking at a salary information, if the salary is over $100,000, no, you should not be allowed. Whatever conditions you want to put, or if the person's title is VP, you cannot, whatever condition you want to put, it gives you the flexibility to import those things. Did I go fast? Okay, sorry. Yeah.
Is it Rego or Python?
Rego is Rego.
That's actually Rego.
That's Rego. Yeah.
Yeah, it looks very much like Python.
Yeah. So let me go back. This is Python. This is Rego. Yeah. I want to clarify. Yeah. So go back. So you have an API client. API client is invoking your API. You can either have your own HTTP filter or you can have an ISTIO proxy that is doing this. With ISTIO, you can have an OPA agent that comes with the ISTIO, which makes a call to your OPA policy service. It gets back the decision and your invocation goes through. If not, you're throwing an error. So let's go back to this. So this is now, how do you integrate OPA? I kind of made the leftmost, which is applications with plugin, right? If you are an API developer, you can put an HTTP filter, right? So if you go to OPA website, there are some default examples for Kafka plugins. There is one for Docker. There is an SSH plugin available that lets you control who can, once you log into the host, what is it that you can actually do. So anywhere in your framework, you can have a plugin. You will be able to leverage this and then say, now all the authorization decision goes through the OPA policy server, and then you can build a policy. You can say, okay, SSH access is open for everyone today, and then you can go back tomorrow, straighten it out, and you can restrict it down based on the file system or certain commands you want to do. So that gives you the flexibility to say however you want to enforce this. There are actually a couple of good talks on KubeCon from Netflix available if you want to look at that. I think I kind of said this. The whole idea of this is that you can change the policy. There is a new concept. This is relatively new in OPA, a bundle. So what that means is that OPA can automatically go and query, hey, do you have new policies available? So once you deploy OPA, it will go and download the bundle for you, which means when it downloads the bundle has the policies. It has any additional data that you want, and it can make the decisions for you. So you don't have to push new policies. It can automatically get the new bundles.
You can essentially hot swap.
Yeah, hot swap the policies. Yeah. I forgot to mention, it also has an API available where you can get what authorization decisions were made. So once you deploy the policy, you can go and say how many requests were successful and how many were denied. Yeah. ISTIO runs pretty much as a sidecar within Kubernetes deployment, and there is a plugin available when you're deploying ISTIO. So that's why it kind of makes it easier to use OPA with ISTIO, but you're not tied to ISTIO. So the main takeaway is it's less about OPA, but I allow OPA because it's kind of more externalizing authorization at the same time. It's also developer friendly. This is one of those areas where you get both the development team and security team to kind of come together.
OPA is easier to handle than ZACML?
OPA is much more easier to handle than ZACML because in terms of both as a ZACML, I wanted to put the syntax. It's a huge XML document. Yeah, right. It's a huge XML document. It's hard to understand what it is. So the time that you would spend with the development team and security team, the conversation takes longer. Whereas with OPA, you can just simply tell them, capture all the requests you want, invoke this endpoint, let team X handle what the policy is supposed to be. And then you can train them to say, okay, you can write your own authorization policies. So that's why it kind of makes it easier.
With ZACML, there was also problems with scalability once you get into millions of things without
Yeah.
getting too specific. Is this a problem here or no? Not so much.
Not so much right now, but it's also an early adopter right now. So but it's most of the time runs in memory, and it's scalable, and you can pretty much scale it like you scale any API. So, yeah. The integrations with REST API is you don't have to train any developer how to integrate their invoking as any other API. The policy and data are available within the bundle, or you can even query additional resources to get the data that you want. That's about it. Just want to give a shout out to the Kubernetes and OPA community. Much of what I said is available online, but it's about trying to pick and choose. The one takeaway you want to do is about externalizing authorization from the code so that you have visibility into the authorization decisions you can make. There are a lot of good people blog about OPA. You can find out or just reach out to me. I'll try to get some information. Yeah. Thank you.
Are there any tools to audit the policies to look for mistakes?
There is nothing right now, but the only thing is it's not a mistake. Like I forgot to mention, OPA itself exposes an API that says what the decisions were made. So if the decisions are, it's either say success or failure, allow or deny, or undecided. So if you monitor those API endpoints, you will be able to say whether is this a mistake, false positive, or am I getting access denied because of some other. Yes.
It's more about real-time auditing as
Yeah.
opposed to coming in after the fact.
That's right. Yeah.
Actually, it's a query language, so you can go and say, okay, who has access to what? So you can build your own.
Okay.
Yeah, so it's actually query language. You can run any queries you want on your policies. So that's, I think, one of OPA. Yeah.
Yeah, OPA uses Regal,
Yeah,
so yeah.
yeah. So that's, I think, the beauty of it, and that's why we adopted it. It's really helpful. It's like you're querying a database of policies.
Yeah.
So this approach that you're talking about, does it work in addition to using an API gateway, or is this an alternative to using an API gateway?
You can actually use it in addition to API gateway. So depending on if you're using a commercial API gateway, most commercial API gateway will allow you to write your own custom plugin. And in that chain of things, you can say, okay, now I've done what the gateway tells me to do, or what the gateway is configured to do. Now I'm going to make an external call to make the decision. So you could do it at the gateway layer. Yeah. Okay. So the ISTIO acts like a gateway, but it goes with your API deployment. Whereas if you have building a bunch of APIs without ISTIO, without Kubernetes, and you have a commercial gateway solution available, then you can have an extension built in to query OPA to make the additional decisions you want.
So, and I'm assuming like a big advantage of this approach is for development teams to be able to write their own sort of custom security for their own APIs, right?
That's right.
As opposed to having it centrally managed in the API gateway by one central team.
That's right. Yeah.
But if development teams are given access to do that stuff in the API gateway, would that kind of solve the issue? And not
You're oftentimes when you're depending on how you're looking at it, like when you deploy the API and you deploy the gateway, and you go have somebody go and configure it, right? But then you can only do so much at the gateway layer at the role-based or attribute-based information. But the moment you have to look at business logic decisions, like depending on how the APIs are written, if you can do a salary approval if about certain number, all those conditions you want to do, you're writing those logic anyway in the code. You kind of abstract them out and then say, now this is not my business logic code, it's my security decision-making code. Now I'm going to make it outside.
So you need more like dynamic authorization.
Dynamic, yeah. When you need dynamic authorizations, when you need fine-grained authorization, you can do it.
Things you can hard code in like to an Okta or like an API.
That's right. When you go through the Okta or any other external vendor mode, what you're saying is, I'm going to make some decision, and then I'm going to add additional custom headers that tells me what you can do, and then your code is looking for those specific HTTP headers to make the decision. Now you externalize this.
Okay, cool.
The other thing you can use it for.
So you can use it to authorize other things than APIs. So you can do Kafka topics or Thrift calls or even Web Console. So
Exactly. Thank you.
you have all your authorization kind of policies or server in a centralized location in a standardized way. So it's easy to do auditing and monitoring in there.
Yeah.
So if you basically do it in the API gateway, then you will have to have other authorization layer for your Kafka topics or what have you. So you're back to that fragmentation. So.
Other thing, like we tried allowing development teams to get into doing what you're asking on Apogee, for example. And we ended up getting our Apogee environment because you have to have administrator privileges essentially to do a lot of that stuff. So if you have like a pass-through out to this, then maybe you can let them do their own policies, but you still keep administrative control. We ended up having to trash a whole Apogee environment because, different teams did different things and started stomping on each other's stuff, and there isn't really enough separation of there's a hard way. It's difficult to chop out areas where people could go and administrate their own stuff, and letting too many people into Apogee as an administrator turned out to we had to reinstall stuff basically and clean it up. So it was kind of a pain. So this might actually chunk things out where they can submit the policies, but you still can have you don't end up trashing the front end of your API platform.
You guys are all on the same camp.
These are easy times, right?
We don't work together there.
We don't work together, that's right, yeah.
So if you're,
But these problems come up. Though.
And I didn't pay them here, so,
I just met him today.
yeah.
if you're using like a tool like Rancher, right? Do you have to route that through OPA or
So
or
Rancher
can it
gives,
work independently?
so I haven't looked at the Rancher's plugin mechanism, but Rancher gives you more control to deploy into multiple Kubernetes thing.
Right.
So when this goes in. So think of OPA as a plugin. So if what Rancher provides you is not enough for you, then you should look at the Rancher's API enforcement and say, can I put a plugin within the Rancher's execution model to say before you go deploy some container on either on Google or your own internal cluster, you want to enforce certain condition, then you can enforce this plugin in the Rancher's pipeline. So like you mentioned, OPA can fit into anywhere you can put a plugin in. It can go into your SSH authentication. It can go into your Kafka topics as a good example. So I can think of I always look at, okay, anyone says, okay, here's my authorization. I say, okay, can I customize it because I don't know what my rules are going to change tomorrow. So when I'm buying a product, so then if I can customize it, then I'm going to put a plugin in there. If I'm going to put a plugin in there, can I just use OPA in this case?
Mm-hmm.
Yeah.
How about managing a lot of clusters with OPA? I mean, is it something you deploy per cluster, or is it something best?
Yeah, it goes by namespace.
Universally,
It goes by namespace, and you can put a service proxy in front, right? So at the end of the day, OPA is an API invocation, right? So if you have an Envoy proxy, for example, in front of this, it can then send the traffic to appropriate policy endpoint if you want, or you can scale it like you scale any normal API.
Okay.
Yeah.
You were talking about maybe using this sort of policy thing to decide which cluster you wanted to deploy something into, or what some developer might be able to deploy into.
Right, I'm wondering what kind of options you have with it. Will it work? So I'm just wondering what kind of options you have with it, what it brings to the table, because you can certainly do things with probably OPA to control who's talking to who within a cluster. That seems like a very good use case. But it also might be across clusters, and you also might be able to do something with. So it seems like there's a lot of flexibility there.
There's on the other side, I just want to mention, so if anybody's going to look at seriously on OPA, you should also consider, you must have seen Brian's presentation yesterday about SPIFFE, SPIFFE. So someone responded to my tweet this morning. So SPIFFE is basically distributed authentication. It's about service level authentication. So one of the challenges, if you have Kafka traffic, for example, no human interaction. You have another application that is talking to a Kafka queue, right? So how do I tell this app 1 to talk to an app 2, right? So you can issue identities to each of those applications, servers, and now with OPA, then you can now derive the identity. Now you can control authorization. So that's where things will become standardized, right? So you use SPIFFE to issue identities, you use OPA to enforce authorization, and you're not bound by someone telling you, configure this application, create a service account here, issue a certificate there, configure the username and password. Now you have an identity for your application. Now you don't need to do this 5 steps. Instead, you let the system talk to each other, speaking the same protocol, which is SPIFFE for enforcing identity, OPA for enforcing authorization. Yeah. Great. Thank you. Thank you. Yeah.